One last thing you took a look at in the enzyme lab was how inhibitors affect chemical reaction. And in particular, you were interested in finding out, well, basically you're given two different inhibitors, one called inhibitor X and the other one called inhibitor Y. And what your goal was you're going to try to figure out if X was a competitive inhibitor or a non-competitive inhibitor. And you're also going to try to find out if inhibitor Y was a non-competitive inhibitor or a competitive inhibitor. So to be able to understand how to make that determination, it'll first help to know a few basic things. So first, basically what is an inhibitor? Generally speaking, an inhibitor is just something that it's some molecule that prevents the enzyme from working, right? It's a molecule that prevents enzyme from being able to bind to its substrate. There are two general ways that inhibitors work, right? One way that an inhibitor works is like this. So say that this green thing represents an enzyme, and this here's the active site of the enzyme, and this blue molecule represents the substrate that this enzyme normally works on. One way of preventing that substrate from binding to the enzyme's active site is by using an inhibitor that has a very similar shape to the substrate. And so if it has a very similar shape to the substrate, you might see how this could block the chemical reaction from occurring. Because of its similarity in shape, it could just as easily bind to that enzyme's active site. And when it does so, it prevents the real deal, the real enzyme, from getting in there and being converted into product. So whenever you have an inhibitor that works like this, an inhibitor that basically competes directly with that substrate for binding to the same spot on the enzyme, that's referred to as a competitive inhibitor. Right? And again, here's its definition in words. Other types of inhibitors work in a little bit different way. The way that these types of inhibitors work is that they actually bind to a different spot on the enzyme other than the active site. Right? So here's a different type of inhibitor that works by binding to a different spot on the enzyme called the allosteric site or the regulatory site. And by doing that, well, it might not be obvious. Well, how does something binding way down here, how would that prevent this substrate from binding to its active site? The way that these inhibitors work is that after they bind to this other spot on the enzyme, it induces or it causes this enzyme to change shape so that the substrate can no longer fit into that active site. And so whenever you have an inhibitor that blocks a chemical reaction in this way, it's called a non-competitive inhibitor. Right? Basically, again, because it's not competing directly with this substrate for the same spot on the enzyme. It's binding somewhere else, so it's not really competing with it. And so in words, a non-competitive inhibitor, again, binds to a different spot on the enzyme versus the substrate. What that does is that it causes the active site to end up changing shape so that the substrate can no longer bind. So again, during our lab, you were given two different inhibitors, and it was kind of your goal to figure out if those inhibitors were the competitive type or the non-competitive type. The way you can figure that out is by knowing or by understanding this little tidbit. It turns out that one of these two types of inhibitors, you can basically prevent them from working by just jacking up the amount of substrate. Here's what we mean. So say that you're considering a competitive inhibitor. In this particular case, right, there's one substrate in this picture, there's one inhibitor in this picture. There is about exactly a 50% chance that this inhibitor will get to the substrate, or that this inhibitor will get to the active site before the substrate does. So there's a 50% chance in this situation that the chemical reaction will not occur. What if you end up just jacking up the amount of substrate? Now you just increased the chances that the chemical reaction will occur because there's a lot more substrate, meaning that there's a lot better chance that one of them will get to the enzyme before the inhibitor does. Right? So basically, if what you have is a competitive inhibitor, then you can get your chemical reaction back by just adding a lot more substrate. That's not the case if what you happen to have is a non-competitive inhibitor. Right? So here, let's say that you try to prevent this inhibitor from doing its job by just jacking up the amount of substrate. Well, because of the way this non-competitive inhibitor works, right, jacking up the amount of substrate really ain't going to prevent this thing from doing its job. Basically, it's going to laugh, right? It's going to go, hey, you just increased the amount of substrate. I don't really care because that doesn't affect the way that I bind to this enzyme. I can still bind to this spot on the enzyme just as well, even if there's a bunch of substrate around. And so because it can still bind to its spot on the enzyme, that means that it can still cause the enzyme to change shape, which means that it can still prevent that chemical reaction from occurring. So the bottom line here is this. We just mentioned that of these two types of inhibitors, competitive and non-competitive, it's competitive inhibitors only that can be overcome by increasing the amount of substrate, right? You can get your chemical reaction back with competitive inhibitors if you just jack up the amount of substrate. Here's how you can visualize that using a graph. Right? So your lab manual and I suggest a bar graph for this as the best way to kind of visualize what's going on, so that you're taking a look at the reaction rate of different conditions, basically. So say that you graph the reaction rate that you get from adding 5 milliliters of substrate together with 5 milliliters of enzyme. Well, you would expect that if an enzyme and a substrate together, then it'll produce a pretty fast reaction rate, relatively speaking. In your experiment, you then set up a reaction where you added an inhibitor, either inhibitor X or inhibitor Y. And so then what you would expect to happen if an inhibitor is added to a chemical reaction is that it'll kind of slow down that chemical reaction. Right? So that's kind of expected, and hopefully this is what you end up seeing. Here's where the concluding happens. Here's where you start thinking. So again, your goal is to find out, well, what type of inhibitor is this? You can figure that out by basically repeating this chemical reaction, but by just jacking up, adding a lot more substrate this time as compared to this time. So if you add a lot more substrate now, and if you happen to see your chemical reaction, the reaction rate comes back, then basically this is showing that, adding the amount of substrate basically now prevented this inhibitor from doing its job. And so we discussed already what type of inhibitor this would indicate. If, on the other hand, you do this so that you repeat this particular reaction so that you add a lot more substrate this time, and if you see that adding a lot more substrate really doesn't affect anything, right? The inhibitor is still able to stop the chemical reaction from occurring, then this indicates what type of inhibitor it is based on what we just talked about. Right? So then just things to think about when you're trying to make conclusions on your enzyme experiment.